In the previous video, we didn't quite finish the last example, so we're going to go ahead and do a couple more examples from section 6.2 in this video. So the next problem we're going to look at is problem number 4, and it says in a random sample of 7 cell phones, the mean full retail price was $446, and the standard deviation was $169. Assuming the population is normally distributed, and use the t-distribution to find the margin of error and construct a 95% confidence interval for the population mean, and then interpret the results. Okay, so once again, there are several assumptions that we make about the data when constructing a confidence interval for the mean of a population. Okay, so if you go look on page 312 of the textbook, yeah, it talks about confidence intervals and t-distributions. Okay, now keep in mind that we're not going to use any of these formulas here, okay, because we're going to do all the work in StackRange. Okay, so one of the assumptions is in this section is that the standard deviation of the population is not known. Okay, the sample data that we collect is random. Okay, and either the population is normally distributed or our sample size is sufficiently large, meaning that we have a sample size of 30 or more. Okay, so if we read the problem carefully, okay, we see that we have a random sample. It's a small sample, right? 7 is our sample size. Okay, and then tells us the mean from our sample data, and then the standard deviation of the prices of these cell phones in our sample, okay, which is 169. Okay, and it does say assume the population is normally distributed. So what that means is that the population of the prices of these cell phones, right, when you graph them, they form a normal curve. Okay, so we're assuming that all of these assumptions are met. Okay, so if they are, we can go ahead and construct the interval using the method in this section. Okay, so before we jump into the problem, let's quickly summarize what we know. So our sample size is 7. So n equal to 7 is our sample size. Okay, and then tells us that the mean in our sample, okay, so the mean cell phone price, okay, of the 7 phones in our sample is 446. So x bar is equal to 446. Okay, and then the standard deviation of the prices of the cell phones in our sample was 169. Okay, and the problem is asking for a 95% confidence interval for the population mean. Okay, so in other words, we want a 95% confidence interval, okay, for the mean price of all cell phones in the population. Okay, so the problem doesn't specify like what phone, right? Whether it's an Android or iPhone or whatever, right? It just says cell phone. Okay, but that's what we want. So what we're going to do is we're going to go to StackRange. Okay, so go to stat, t-stats, right? Since this type of confidence interval involves the t-distribution, right? We're going to select t-stats. All right, since we're working with one sample only, right? We're going to go to one sample and then select with summary, right? We don't actually have the price of each phone in our data set, right? We have a summary of the data set, meaning we have the sample mean, the sample standard deviation, and the sample size, right? So that's a summary of our data set. So we're going to select with summary. Okay, the sample mean goes in this box here, which is 446. Standard deviation goes here, which is 169. And our sample size was 7. Okay, always make sure that you select the second button for confidence interval. Okay, and our confidence level, according to the problem, was 95%. So when you convert that into a decimal, it's 0.95. Okay, which is already selected. And if you want to, you can select this box to create a graph of your interval. Okay, so after you click compute, it tells us that we have a 95% confidence interval for the population mean. Okay, the mean of our sample was 446. Standard error was this number. The degrees of freedom, which is sample size minus 1, is equal to 6. Okay, but what we're looking for are the lower limit and upper limit. Okay, we're going to round those to 1 decimal place. So 289.7, and then 602.3. Okay. It does say identify the margin of error. Okay. So what we do. Okay, so unfortunately, this doesn't tell you what the margin of error is, right? So the problem is assuming that you're using the formulas to calculate the margin of error, right? Which we're not doing. Okay, so in this case, right, what you do is you take upper limit minus the lower limit, and then divide the difference by 2. Okay, so you have 602.3 minus 289.7. Enter, and then divide that by 2. So in other words, I'm rounding these to 1 decimal place because once our final answer round is 1 decimal place. So to 1 decimal place, the margin of error would be $156.30. Okay, and that goes in the answer box there. All right, and the units of our answer are the same as the units for the sample mean and the standard deviation. Okay, so then it wants the actual confidence interval. Okay, so the lower limit was 289.7, so $289.70. And then the upper limit was $602.30. Okay, so then once we have that, we want to select the answer choice that best represents the interpretation, and it looks like we're going to have to fill in some of these boxes. Okay, so really quickly before I select the correct answer choice here, right, I've written out the interpretation that we're looking for. Okay, so here it is, right, we are 95% confident, okay, that the mean price of all cell phones in the population is between $289.70 and $602.30. Okay, so any good interpretation of a confidence interval, right, includes the confidence level, which is this piece here, the parameter of the population that you're estimating, okay, and being as descriptive as you can, right, not just saying population mean, that's not descriptive enough, right? Remember, we're estimating the mean price of all cell phones in the population, so what I do is I literally write that out, right? The mean price of all cell phones in the population is between 289.70 and 602.30. Okay, so then we select the correct interpretation. So you'd have to read these on your own, okay? But I believe answer choice D would be the most appropriate. So then we're typing the confidence level, which is 95%. So in other words, with 95% confidence, it can be said that the population mean full retail price of cell phones in dollars is between the interval's endpoints. So that's kind of like what we wrote here. Okay, so it looks like answer choice D would be the most appropriate choice. All right, and we're ready for the next question. Okay, so the next problem we're going to look at is number 7, and it says, the annual earnings in dollars of 35 randomly selected microbiologists are shown in the table. Use the data to A, find the sample mean, B, find the sample standard deviation, and C, construct a 98% confidence interval for the population mean. Okay, so in this problem, right, the raw data are given to us in the problem instead of a summary of the data. Okay, so in the previous 2 examples that we did, the one before this one, and then the one before that in the other video, right, each had a summary of the data, right, the sample size, the sample mean, and the sample standard deviation. But here we're given the actual data values. Okay, so we're going to go ahead and copy and paste the data into StatCrunch, then determine the sample mean and sample standard deviation. Okay, so that's our first order of business. So copy the table. You can also open it in StatCrunch directly if you don't already have StatCrunch open, but I already have it open, so I'm going to copy to clipboard. Okay, and then we're going to go to StatCrunch. And then in an empty column, Okay, we're going to input the data. Okay, so if you see this little box here, if you copy and paste, let's go ahead and select none. Right, let's put the data into a single column, just like that. Okay, you want the data in a single column rather than several columns. All right, you can rename the title of the column if you like. You can call it salaries. Okay, for convenience. All right, and then what we do is we go to stat, go to summary stats, and then select columns. Okay, then you can select the column that contains the data. All right, so let's get the sample size, the sample mean, and the standard deviation. That's what we need. Okay, this would be the mean of the sample, and this would be the standard deviation, and then this is our sample size. Okay, we're going to round our answer to 2 decimal places. Okay, so to 2 decimal places, this would be 71,944.31. Okay, and then the standard deviation of our sample. Okay, also rounded to 2 decimal places would be 15,415.40. Okay, and then we're going to do what we did before to obtain the confidence interval against StatCrunch. Okay, so let's go to stat, tstats, and then select one sample. So since we have the data, right, we're going to select with data this time. Okay, before we only had the summary, so we selected with summary, but now we're going to select with data. Okay, anytime we have the raw data values. Okay, select the appropriate column. Make sure the second button is selected, and remember the confidence level changes from problem to problem. So we want a 98% confidence interval. Okay, so as a decimal, this would be 0.98. Okay, so I'm going to replace that with 0.98. Okay, we don't need the other options here, so I'm just going to go ahead and click compute. Okay, and what we're looking for are the lower limit and the upper limits of our interval. Okay, so the lower limit goes in the left box, and we're going to round it to the nearest whole number. When it says round to the nearest integer, it means to the nearest whole number. Okay, so the lower limit to the nearest whole number would be 65,583. Okay, and then the upper limit would be 78,305. Let's check our answer. Great, so this is how you do problem number 7. So hopefully you've seen enough examples to know how to do the homework for the remaining problems in section 6.2. So before we end the video, remember it's always a good idea to practice writing an interpretation. Okay, so an interpretation for this confidence interval that we just did is as follows. We are 98% confident that the mean annual salary of all microbiologists is between $65,583 and $78,305. Okay, so the interpretation should always be written as a complete sentence, right, and it includes the confidence level, the specific parameter that our confidence interval is estimating. Okay, so it's the mean of a population. Okay, but specifically what is it the mean of, and of what population? Okay, it's the mean annual salary of all microbiologists. Okay, and it could be in a particular region or in a particular country or whatever. It doesn't specify, but it's the mean annual salary of all microbiologists. Okay, that's what we're estimating. All right, and then it includes the confidence interval limits. So we end it with right is between $65,583 and $78,305. Thank you for watching.